Math is great, math is okay. You will need in life every day, from pandas to functions.
5. Use factoring by grouping. So this is today's lesson, factoring by grouping. To factor, identify the zeros and sketch. We've been doing those 3 things, but now we have a different method. I'm going to show you guys 2 ways of doing this. This first method I call 2 GCFs. And I think I know what most students will pick. The next one is the box method. Okay, let me show you guys 2 GCFs. If that doesn't make sense to you, then you can try the box. I'm going to rewrite the problem. X to the third plus 7x squared minus 4x minus 28. Back in August, when we did a small unit on just factoring quadratics, we had a map that kind of showed us that you use factoring by grouping when you have these many terms. 1, 2, 3, 4 terms. Anytime you have 4 terms, then automatically you're going to use factoring by grouping. So let me show you guys what the 2 GCFs are. In this method, I'm going to cover up the last 2 terms and figure out my greatest common factor. Class, what's the greatest common factor there? X squared. What's left? X plus 7. And then, I'm going to take the greatest common factor of the last 2 terms, and you know you're doing this correctly if your parentheses is the same. What's your greatest common factor there? Negative 4. And what goes inside the parentheses? X plus 7. So let me highlight that in red. These in the parentheses are exactly the same. Okay, I call that the first GCF. Here is the second GCF. You'll notice that they both have red in it, x plus 7. So x plus 7 is their greatest common factor. Now I'm going to write everything that's not in red. That would be x squared minus 4. And then we just did that problem in our warm-up. X squared minus 4 is put a 0x in there, and that'll become x plus 2, x minus 2. So there I factored using a method called 2 greatest common factors. Take up GCF, GCF, that's the first one. The second one is in red. The other method, the second method, is called the box method, the area model. And we've actually done it before, it's really familiar. And I'm going to use a pink highlighter. I just found this to be helpful. Maybe it'll be helpful to you. The 4 terms, you're going to write in the form of a Z in the box. Now, could it work if you randomly put all the 4 in there? Yes, but I just noticed that it's always organized nicely if you do it this way. So I'm going to write x cubed, 7x squared, negative 4x, and negative 28. And why the box method is really popular with students is because we've been using Xbox method of factoring. And we're basically going to do the same thing. Class, what is the greatest common factor? X. What's the greatest common factor? What do they all have in common in there? X squared. What do they have in common here? And what do they have in common here? Positive or negative? So I have x plus 7, x squared minus 4. And we just did the same problem there. That just expands to be positive 2 and negative 2. Thanks. Okay, so what we have here is we did 2 methods, and you only need to use one of them. So right there we just factored. And then to identify the zeros, just to finish off the problem, this should be a quick review. Costs, partner B, tell partner A, how do you identify the zeros given the red box? On the count of 3, you guys are going to tell me what to do. Ready? 1, 2, 3. Set it equal to 0. And when you solve the problem, here, x is going to be equal to what? -7. Here, -2, and +2. So let's make our sketch. Label your sketch, -7, -2, +2. Although you have a polynomial, multiple terms, the highest degree is 3. So that's going to be a cubic. Odd degree starts down, ends up. Let me just sketch it. Notice your multiplicity here is 1, so those are odds, which means they're going to be shoot-throughs. You also have a y-intercept of -28. And a graph looks like this. In this problem, we are learning about a new method called factoring by grouping. It works with 4 terms. You can either use 2 GCFs or the box, and then we identify the zeros and then sketch the polynomial. Alright, in this problem, you're asked to factor. Now, I don't necessarily like this method, but it only works in a very particular case. If you look at the first 2 here, I can do something like y equals, what do they have in common? 3x. So then we can say this is 3x squared plus 3x minus 2. And then we can have y squared. This is your substitution, right? Every time I see 3x, I'm going to write y minus 2. And you're essentially still doing your x box. 1 and 1. This is your a, b, and c. A times c is -2. B value is +1. 2 numbers that multiply to be -2 but add to be 1. +2 and a -1. So those 2 values, 2 and -1, is y plus 2, y minus 1. And then I'm going to go back and put in my substitutions. So I have the answer of 3x plus 2, 3x minus 1. Raise your hand if you got that. If you chose to use the Xbox method for this one, there is no greatest common factor. A times c is -18. My b value is 3. 2 numbers that multiply to be -18 but add to be 3. (6) and -3. So I put those in my box. So I'm going to have to add an x because we're basically splitting the middle term here. Your first term, last term. The greatest common factor here is 3x. In this direction is 3x. This direction is a -1. Remember, you can always multiply to check. And 3x times 2, because that is our greatest common factor in this direction. So I have 3x minus 1, 3x plus 2. Raise your hand if you got that as your answer. Then we're going to write down the formula, substitute, and fourth, we're going to simplify. Okay, so in this problem, step number 1, let's go ahead and take the cube root of both of these. In the previous introductory video, you should have seen that the cube root of 8 is 2. So let me show you. A equals the cube root of 8x to the third power. So we need 3's to come outside of this scary neighborhood, so it's 2 times 2 times 2, and x times x times x. So there's, change colors today. That one can come out, right? That's a 2. And then over here, this one can come out, and so that becomes an x, okay? So a equals 2x. Let's basically do the same thing for this other one here. So b equals the cube root of 1. 1 can be broken down as 1 times 1 times 1. There's 3 of them there, so they can come out here. And basically what you have is b equals 1. Okay, so that's how you find your a and your b. Okay, so what is our formula? Well, notice that we have, use purple. You have a minus sign. So in your formula, you're essentially going to use a minus b cubed equals ab a squared ab b squared. And then the signs, here it is, same, opposite. What's opposite of negative? Positive. And then AP, always positive. Okay? And what we're going to do here now is just substitute in our values. A is going to equal 2x. Let's make that a little bit thicker. And then b value is 1. B value is 1. Let's go ahead and put those in. Use, oops, change my text. Okay, so a value is 2x, and when I do that one, I chose to use a bracket. Why did I choose to use a bracket? Because you might use more math operations than those. Your b value is 1. Remember, brackets and parentheses are pretty much the same thing. It's just an extra set of organization here. A is 2x, and notice how it's the power of 2. Plus, the a value is 2x. Okay, so why did I choose to go back to parentheses? Because I don't have, you can keep this brackets. It's not wrong. And the b value is 1. Plus my b value is 1. Okay, so now we just need to go back and clean this up. So I have 2x minus 1. Okay, clean that one up. Okay, be careful here. This one's 2x squared, which basically means 2x times 2x, which is 4x squared plus 2x, and 1 squared is just 1. So if you wanted to factor 8x cubed minus 1, your answer would be 2x minus 1 times 4x squared plus 2x plus 1. Let's highlight that. This is our answer. Alright, go ahead and put your finger on the word chunking on that page. See it? See it in a couple of places. So I'm going to show you guys how to use this method of factoring by chunking. It works only in particular cases, and I'm actually going to show you that even if you don't see it, you can still do the problem. So let's split this in half. On this side, I'm going to show you guys chunking. And how would I define chunking? Chunking factoring. Try to focus. It is a GCF of the first two terms. chunking is equal to the greatest common factor of the first two terms, not all of them. Put your finger on the first two terms. Right there. If I do a think out loud or think to myself, this is an odd number, this is an even, this is an odd. They do not have a number in common. They don't have a greatest common factor. But in the yellow box they do. Partner A whisper to partner B, what's the greatest common factor? Angel C, what's the greatest common factor in the yellow box?
5.
5. 5 and an X, right? Okay, watch what I'm going to do. I'm saying that this is equal to this. So 5x squared, because class, what's 5x times 5x? 25x squared. Something times 5x equals 20x. What is that? 4. And I'm going to put down this minus 21. And for those who go on to more math, basically what this is you can write above chunking, this is actually a substitution. So the math gets so complicated you just have to do side problems. So our substitution is going to be 5x is equal to your favorite shape. I'm going to choose a box. Every time I see 5x, I can write a box. Class, I see 5x. What can I write there? Box squared plus 4 box minus 21. Why did we do that? Now we have an easier problem to use the X method of factoring. Class, what's A times C? And class, my B value? It's 4. Partner B tell partner A, what are the two numbers? What are the two numbers that go there? Tony?
Yeah. 7 and -3.
Because my A value is now equal to 1, pay attention, I can just put these two numbers in here, 7 and -3. So I have box, 7 is positive, times box minus 3. In class, what is the box equal to? 5x. So my answer is 5x plus 7, 5x minus 3. Here we just factored. Now, this is not the complete problem, but I just wanted to box that because we completed a part, we factored. So there is chunking, solving, and then making a sketch. But what happens if you look at this problem and you don't see a chunk? So I'm actually going to show you no chunking or no chunk, and I'm going to call this just X box. And let's see if what we already know gets us the same answer, but is a little bit more familiar to you. I'm going to rewrite the problem. And let's do that together. You might need your calculators. Class, what is A times C? $25 times -21? Thank you, Angel. -525. Class, what's your B value? 20. We need to think of all the numbers that multiply to be -525. Feel free to use your calculators or the ones in your heads. Yeah, what are your two numbers?
Get 2 and 45.
15 and... Is it 35?
45. Not 35, yeah, 35.
So I have 35 and 15. How about 5? So I'm going to do 525 divided by 5. Just get a couple of numbers out there. Well, we only have 2 combinations there. Class, which one works? First one here. Partner B, tell partner A which one is negative and why. Class, which one is negative?
15.
Now, question. I'm going to ask the question and then just show me your thumbs. Should I put 35 and negative 15 into my factors? Show me your thumbs. That's a no, right? Because you only use the x when a is equal to 1. But when a is greater than 1, you have to use both the x and the box. Say that again. Class, is this number bigger than 1?
Yes.
You have to do both. Yes, very good. Okay. Now, if you don't understand that trick, if a is equal to 1, you can actually use both still x and the box. The shortcut is when a is equal to 1, you only have to use the x. Okay, let's fill this out together. Let's pretend you've never seen this before. Some of you have seen this before. Class, what goes in the very top left box always?
X squared.
The first term. So that would be 25x squared. Always. Class, what goes in these two boxes? We're basically splitting the middle term. 20x, which is 35x, and negative 15x. So you have to add an x there. They will always go in these positions. Now, you can always switch the orders. You can have 35x and negative 15. And then, class, what always goes in the bottom right? Negative 21. Okay, with your partner, go ahead and take 30 seconds. I want you guys to find the things on the outside of the box. Ready, set, go.
5x plus 7. Plus 7. Plus 7.
Don't worry, don't worry.
Oh!
Daphne, what did you get on the top here?
5x minus.
Thank you. And Elijah, absent. Natalie, R. What did you get on this side? Out here? Yep. 5x times 5x is 25x squared.
And 7.
So we have 5x plus 7 and 5x minus 3. Oh, look at that. it's the same.
That's crazy.
So, let's review. You can factor this problem in two ways, chunking or Xbox. You can set it equal to 0, they'll be the same, right? And then you can solve it to make a sketch. Braxton and Kenny both factor the polynomial expression x cubed plus 2x squared plus 4x plus 8. Class, how many terms are there? 4, so they would have factored by grouping. Analyze the set of factors in each student's work. Describe the set of numbers over which the students factored. The set of numbers, I'll explain right now. So in the family of numbers, there are numbers called complex numbers. Write down this family tree. And in this family, complex numbers can be divided into, anybody know? What do you think those stand for? Real numbers and imaginary numbers. And as I was helping a student study for the SATs yesterday, imaginary numbers starts with what word? I. Partner A, tell partner B, what's the formula you know about I? Brendan, what do you know about I? Okay, in this class we have not gone over the next one, but just imagine, what would happen if I squared both sides? I squared equals -1. And real numbers, I just call it they're on the x and y plane. This is the x-axis and this is the y-axis. And if people ask me, what do you do? I say, I'm a math teacher. And they say, what do you teach? I tell them I teach Math 5. And they're like, what's Math 5? Because 10 years ago, there was no Math 5. They called it Algebra 2. And then the reals you can call Algebra 1. So, Braxton solved over what? Which number set? The real number set. How do we know that? Do you guys see any I's in there? No. Kenny solved over what? How do you know the imaginary? You see I in there. Okay, so what's the difference? You have 4 terms of polynomial. They appears that they did the method that I called 2 GCFs, right? They looked at the first 2, they found the greatest common factor, found the GCF of the second 2, and they got this. Now let me highlight that. Back in Algebra 1, Braxton would have said, okay, x squared plus 4 is a prime factor. I cannot factor anymore. But Kenny, who's in this Math 5 class, this Algebra 2 class, took one more step. Well, x plus 2's are the same. This is what's different. X squared plus 4 turned into x plus 2i and x minus 2i. How did Kenny do that? Can Kenny factor from here to here?
Yes. No.
Kenny didn't use the Xbox method. Kenny used the quadratic formula, and his answers then Kenny can put into x minus this, x minus this.
So if you can't factor, just use the quadratic?
Yes. Very good.
So find what.
Alright, so I'm going to show you guys chunking or substitution by using this example here. 49x squared plus 35x plus 6. I first look at all of the numbers, the constants, and recognize that there's no greatest common factor. Then, This chunking or substitution method only works in a particular case. If I look at the first two, I have to think to myself, does it have anything in common? Class, does it have anything in common? Yeah, I can make that letter, we'll make it a z. Z is equal to 7x. So 49, I'm just going to rewrite the problem. 49x squared plus 35x plus 6. And now I can write 7 parentheses 7x squared plus 5 times 7x plus 6. Do you see that? There's my chunking or my substitution. Instead of writing 7x, I can write what variable now? Z. So let's write that. Z, I like to draw another line through it, z squared plus 5 times z plus 6. And now can I use my Xbox factoring? Yeah. Two numbers that multiply to be 6. And two numbers that add to be 5. Class, what are those two numbers? 2 and 3. So I have z plus 2, z plus 3 that I got from my factor. And then we just finish up the problem by going back here. Instead of writing z, class, we can write what? 7x plus 2, 7x plus 3, and this is my answer. So I showed you guys factoring by using chunking or substitution, and now I'm going to show you guys how to factor the same problem using the Xbox method. In the Xbox method, I'm going to use A, B, and C. So if you have your calculators out, A times C, 49 times 6, will give us 294. And then my B value, which is how much? 35. I need to think of two numbers that multiply to be 294. But the same two numbers there will also add to be 35. Now, what can you do with such a large number? Well, in your calculator, you can do 294 divided by 2. If there's a remainder, that means it's not a factor. If I divide it by 3 or 4 or 5, and you keep going and increasing those numbers. Well, you play around with it. You have the ability of your calculator. And then those two numbers are, anyone find them? 21 and 14. On your quiz or test, I won't give you such a large number. Let's go ahead and put this in a box now. I have 21, and I'm going to add x. And 14, I'm going to add x. And the reason why you add x is we're basically splitting the b term. In the top left will always go the a term, 49x squared. And the bottom right, what am I going to put, class? 6. That's always the c term. How do you get the numbers outside the box? What's our greatest common factor here, class? 7x. Greatest common factor here? 3. Greatest common factor this direction? Greatest common factor. And you can always multiply to check. 7x times 7x is 49x squared. 2 times 7x is 14x. 7x times 3 is 21x. 2 times 3 is 6. And then my answer is 7x plus 2. 7x plus 3. Class, did we get the same answer? Yeah. So this one, you had to work with larger numbers. Again, in our examples later on, I won't give you such large numbers.
Missing formulas in life. Problems becoming too difficult to clear. Well then, you need Mr. Math Cleaning Solution. Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. Stay clean and calculated. Order now at www.gpproductions.com and get an additional